Imagine you are 50 years old and you have no picture of your childhood. What would you give to see how you looked as a child? One day, a person comes and offers some pictures of your childhood. That person is James Webb Space Telescope. It is not a telescope but a time machine. But how will it help us see the earliest pictures of the universe? Will it even help us see the primordial black holes? The first stars did not come into existence just after the universe was born. About 200 to 400 million years after the Big Bang, the universe's first stars emerged. It will be beyond the capabilities of any space telescope to observe those very first individual stars. However, some new theoretical studies suggest under the right circumstances and with a little luck, NASA's upcoming James Webb Space Telescope will be able to capture light from single stars within the first generation of stars. The James Webb Telescope needs to find a spherical star that has been gravitationally lensed. The star's light must be bent and magnified by the gravity of an intervening galaxy cluster. But not every kind of gravitational lensing can offer the same result. Typical gravitational lensing can magnify light by a factor of 10 to 20 times, which is not enough to make a first generation star visible to the Webb. We have to remember that those stars are billions of light years away. As the universe expanded, and sometimes expanded even faster than the speed of light, the first stars now are not only long dead, but their light may never reach us. But there is a way to see them. If the distant star and the galaxy clusters closer to those stars are in the same line with James Webb's field of view, the star's light can be amplified 10,000 times or more, putting it into the range of becoming detectable. This could be done using a method that is called cluster acoustic transits, where the light from a first star candidate could be enormously magnified for a few months due to the motion of the galaxy cluster across the sky. But there is a small chance of that kind of precise alignment ever happening. But a recent observation by some astronomers has given us hope. Recently, Hubble spotted a star known as Icarus, which was a super magnified star. Although it was the furthest single star ever seen, James Webb Telescope might locate stars that are much greater distance from it. Scientists using the James Webb Telescope hopes to find a lensed image of a star that formed from the primordial mix of hydrogen and helium that suffused the early universe. They are called population 3 stars. James Webb's work does not end after finding the massive stars. Most of these first stars are dead, but they were massive. So that leads us to black holes. And even some of those black holes have spent enough time for Hawking radiation. Hawking radiation causes black holes to lose their mass and rotational energy, and is therefore also theorized to cause black hole evaporation. Nearly at the center of every other galaxy there exists a supermassive black hole, but scientists aren't sure how they formed. However, we may soon witness how they formed in the early universe. In addition to the first stars, scientists investigated the possibility of seeing accretion disks surrounding the first black holes. Such a black hole formed by the cataclysmic death of a massive star could shine brightly if it pulled gas from a companion star. They are called primordial black holes. They formed early in the universe, just after the Big Bang. But primordial black holes are not necessarily small. Scientists recently found out that black holes grow as the universe expands. So some of the largest black holes are the oldest ones too. I recently made a detailed video about that. Watch it here. If an object shines for enough time, it becomes more likely it will drift into alignment with a gravitational lens. Theoretical studies suggest that the first generation stars should have been massive and short-lived, lasting for just a few million years before exploding as supernova. In contrast, a black hole stripping a companion star could shine for 10 times longer, feeding on a steady stream of gas. As a result, Webb might detect more black hole accretion disks than early stars. The James Webb team calculates that an observing program that targets several galaxy clusters a couple of times a year for the lifetime of Webb could succeed in finding a lensed first star or black hole accretion disk. They have already selected some of the best target clusters, including the Hubble Frontier Field clusters and the cluster known as El Gordo. So, the astronomers know where to look for and what to look for. Now you know too. That keeps up the work for James Webb Telescope. The James Webb Telescope will be launched on December 18, 2021 and start giving us amazing discoveries by July 2022. If you want to know more about James Webb and its mechanism, how it will be launched and its problems, then watch this video.